So you are learning Python decorators. So this is a title here, Python decorators. Python decorators. And in this, what you'll be learning is like, so what is understanding Python decorators, why we are using decorators, and then you'll be talking about like function decorators, and we'll be talking about function decorator chaining. So this is nothing but chaining of, so that is nothing but multiple decorators. And then we'll be talking about class-based decorators, class-based decorators. And next I'll be talking about decorators with what arguments. And next we'll see some applications of decorators, means where exactly these decorators are used. Now this is a workshop title, and this is what we are going to discuss. Okay, so this is, you can say, content. Okay, and duration of this workshop is, okay, duration of this workshop is 3 days. Okay, you'll have a 3 days workshop, and the timings are, okay, you'll have some 9 I'll start, and we'll have up to 10:30. Okay, so these are the timings. So AM, and this is also AM. Okay, so this is a workshop. So in this, you'll be learning the complete, like in-depth knowledge about decorators. Okay, so not just what is a decorator is, you'll be learning everything in details. Okay, you'll be learning everything in detail. Okay, so then next, let me talk about first. Okay, so let me talk about, yes, can you hear my voice, right? Okay, all of you, right? So first we'll see, okay, first we'll see what is a decorator is. Okay, first we'll see what is decorator is, and why we have to use decorators. Okay, why we have to use decorators in, and what is the use of it, and where exactly these decorators are used. Okay, so actually, yes. So first we'll talk about what is decorator. First we'll talk about what is decorator. Okay, so it is very simple. Now, what is a prerequisite for learning these decorators? If you want to learn these decorators, you should have a knowledge of functions. Okay, if you know how to write a function, okay, how to work with the functions, you can attend these decorators. Okay, what is a prerequisite is, you need to know the functions. If you know the functions, you can happily learn these decorators. Okay, right? So what is a decorator is? Okay, so actually a decorator in Python, a decorator in Python is a function. It is a function. Okay, what is a decorator? Decorator in Python is one function. Decorator is a function. Okay. What is a decorator? Is a function that modifies. Okay, that modifies. Okay, that modifies the behavior. That modifies the behavior. That modifies the behavior of another function. That modifies the behavior of another function. It can modify the behavior of another function, or it can modify the behavior of another class also. Okay, behavior of function or class, or it can be what here methods. It can be what here methods. Okay, so actually decorator so decorators actually called as a design patterns. Okay, it is one design pattern. So what is a design pattern is? Yes, that will add functionality. So a decorator in Python is a function, so that modifies modifies the behavior of another function or class, or what is that methods. Modify. I said modify means add the functionality. Modify means in modifies lot of things will be there. One is adding, updating, deleting. Any operation can be done by using decorator, right? So it is not just adding. Okay, okay. It is not just adding. It is not just adding. Okay. So in decorator you can do lot of things, not just adding. That is nothing but like function transformation. Means you are modifying, you are transforming one function to another function. How you are transforming one function to another function without modifying it? So that can be done by using what? Decorator. Yeah, you can say adds a functionality, right? So modifies or add the functionality. Okay. You can write like that also, which adds a functionality to what existing function. But if I say adding, only adding is done. No, a lot of things can be done. A lot of things can be done in what? Decorators. Okay. So that extends, I can say modify, that modifies or extends, that modify or extends. Okay. The behavior of another function or class or what methods. Okay. So generally, decorators are design patterns. Decorators are the design pattern. What is a design pattern? The design pattern, okay, okay, the design pattern generally, what is a design pattern is? Design pattern is what it defines is some set of rules and regulations. Okay, a design pattern defines some set of rules and regulations. Or you can say a design pattern provides you a solution for a given problem. A design pattern provide a solution for a given problem. That is called as a design pattern. So decorators are what here? Design pattern. Okay. So that will provide a solution for a given problem. Suppose what is the problem here is you write a function, you write one function in application development. After writing a function, without doing changes in that function, you want to add some new features. Without doing changes in that function, you want to add some new features. Now, how can I do that? Then the people develop one solution for that problem. And what is that? Is a decorator. Yeah. So you have so many design patterns. Like if you are working with like Django is there. In Django, you are using one architectural design pattern. And what is that architectural design pattern? MVT. which is nothing but model, view, and template. So it is one design pattern that will provide you a solution for a specific problem. It means whenever you develop an application, your application contain lot of functionality. Okay, so they divided that into three layers like model, view, and what is that template. So that maintaining your code becomes what easy. So like that you have lot of design patterns. Okay, lot of design patterns out there. So in that one of the design pattern is what decorators. A design pattern. So that okay, that allows programmer that allows programmers to add what is that new functionality, new functionality, new functionality to existing new functionality to existing function or class or methods without changing the original, without changing what here original, without changing original. Okay, you want the existing class should be as it is, existing function should be as it is, existing method should be as it is, but you want to add some new functionality, you want to change, okay, the functionality, you want to add new functionality. So that can be done by using decorator. So what is a design pattern? No, not inheritance. Inheritance is different. Inheritance is different. Inheritance is different. Decorators are different. Inheritance is different. Okay, both are not same. Inheritance is different. Decorator is different. Inheritance is different. Okay, inheritance means it is like a parent and child relation, right? Uh, parent child, parent child. Yes. So child inherit the properties and behavior of what parent. Is it parent is modified? No, no. Is it? Are you adding any new functionality to parent? Are you doing any new functionality to parent? No, no. Inheritance allows you to develop a new class, a new data type. It allows you to write a new data type by using another data type. That is different. Okay. Both are not same. So yes, this is what is a decorator is. Decorator in general term, if you see decorator, okay, decorator means it is just like a wrapper. Okay, decorators are what? Just like a wrappers. Decorators are wrappers, right? Okay, I mean suppose you purchase a cake. When you purchase a cake, okay, that shop person will ask, you want to do any decoration? Okay, then he'll try to decorate it, right? Means he's trying to add some new functionality. Is trying to add some new functionality, right? So it is just like a wrapper. You purchase a gift, then you wrap that gift inside a wrapper. That wrapper is what? Some adding some extra features or extra functionality, right? But your gift will be as it is. Your gift will not be changed. You are just wrapping inside what? One wrapper. So your wrapper is just like what here? Decorator. Okay. Then here, when to use? Okay, when to use a decorators, or what is the use of decorators? Okay, when to use decorators, or what is the use of decorators? Okay, so I think now I think anyone, okay, like suppose students, those who are attended like Django, right? Okay, so for example, when to use decorators means, for example, okay, suppose simple thing is, yeah, that is what I'm telling you. When to use decorators or what is its use cases. Okay. what is its use cases, when to use decorators. Okay. For example, if you see authentication, okay, authentication and authorization. I said authentication and one more is what? Authorization. Okay, suppose for example you are working with web application development. Okay, web application development. Okay, I have one function. For example, I have one function. What is the function is I read one function or method called withdraw. So whenever a person call withdraw, okay, now what he required some login. So login required. So I write one decorator. What is the decorator I'm writing? Login required. Okay, login required is what here? Decorator. Means this function is decorated with what? A decorator. It means whenever it call the withdraw, it will ask for what? Username and password. That is called as what here? Authentication. That is called as what? Authentication. Okay. Suppose there is one more function. What is that another function? Deposit. So here also I'll say decorator. Here also I'll give decorator. What is the decorator? Again I say login required. Login required. Means once you develop a decorator that can be applied to either one function or more than one function. This is a syntax of applying the decorators. We'll discuss that. It means whenever you call this function withdraw, so this withdraw function required means you added one extra feature. You added one extra functionality. What is that extra functionality? You added a login required. Okay, whenever you call the function deposit, okay, you added one extra functionality. What is that extra functionality? Login required. Getting on it. So it means now this login required is what here? Decorator. We added one functionality to this function. We added this functionality to this function. Okay. We added one functionality to this function or a class or a method. Okay, now this is what all these are use cases. All these are what use cases when I should go for which one? Decorators. Okay, yes. For example, now this is one authentication and what authorization. So what is authentication? Like checking permissions. Okay, so when your application required checking, okay, checking what checking permissions. Okay, checking for what is it? Username and password and access permissions. Okay, access permissions before accessing what your functions, before accessing functions, classes, and what is that? Methods. Before accessing classes, functions, and what methods. Okay, and these are what you call it as use cases, or I can say when to use decorators, or I can say applications. These are some of the applications of what decorators. These are some of the applications of decorators. Okay, I said authentication and authorization. Okay, so this is one. And other one is not only authentication and authorization. For example, now Python is a dynamically typed language. Okay, Python is dynamically typed language. Means once you write a function, that function can receive any type of values, right? Once I write a function, that function can receive any type of values. That function can receive any type of values. Okay. Suppose once I write a function like this, Okay, for example, I write a function 1 or I write a function called add. I'll say a comma b, a comma b. Okay, so then I'll say return a plus b. Now this is my function. Now by default, every function what you write in Python is a generic. It is a generic function. So generic function means, okay, generic function means this allows authentication is credentials, authorization is permissions. Okay, authentication is credentials. Okay, authentication is credentials, authorization is permissions. Okay, permission, permission, permissions. Okay, you enter username and password, correct? Then after that, you will get a dashboard. From that dashboard, you cannot do all the things. You should have some permissions. Okay. So giving username and password is what authentication. After that, to perform certain operations, you required authorizations. Yes. Yes, Akash. Yes. Yes. Okay, na? Yes. So that is the difference between authentication and what authorization. So here I'm writing C equal to add. I'm sending 10 comma 20. Okay. Now when I write like this, now this function will receive two values of which type integers. If I'm writing D equal to add, if I'm writing 1.5 comma 2.5, so this will receive two values of which type float. Yes or no? So if I'm writing E equal to add, okay, if I'm sending like I'll write some Naresh comma some Suresh. Okay, will it all this work or doesn't work? Work. Okay, all this will work. C, D, E. So what is the output I'll get? Now 10 plus 20 is a 30. 1.5 plus 2.5 is 4 point, sorry, 4.0. And Naresh plus Python is Naresh plus Suresh becomes what? Naresh and Suresh. Okay, yeah, we'll see the examples. Jagadishwar. We'll see the example, don't worry. Okay, I'll tell you all the examples. Okay, but just we are learning what is a decorator is. We'll see applications. Okay, so when you run this, okay, when you run this code, is it this code will give any error? No, this code will not give any error. This code will not give any error, right? So if you run this module, now you can see 30, 4.0, Naresh, Suresh, right? So now the functions what you develop, these functions are not type safe. These functions are not type safe. Not type safe. These functions are not type safe. Okay, not type safe means this will work with one type or any type, any type. This doesn't work with one type. This will work with what, any type. Okay, but I want to check for types. Means I don't want this function should work with any type. I want this function should work with only integer type. Okay, only integer type. Then I'll declare one decorator. I'll write here integer. Okay, suppose this is my own decorator, integer. So this is integer parameters. I'll write like this. So this is my decorator. Now what this decorator will do, it will verify is it my parameters are integer or not. If it is integer, then only it allows. If it is not integers, then it tries what? Error. Now suppose in that way I'll write one more function called sub. So this function should work only with integers. Then I may write a decorator. Like suppose integer, I'm writing like what? Integer parameters. Now this should also work with only integers, but it should not work with any other type. Then you are adding one extra functionality, right? What is the extra functionality you added? Parameter checking. What is the what is the extra thing you added? Parameter checking. So I want to check, is it these parameters are valid or what invalid? So this is one more application of using what decorators. That is nothing but some checking what here checking parameter what here types. We'll see all this. I'll tell you examples. All these examples I'll tell you. So checking, it's nothing but some checking checking the types of parameters, types of parameters during what runtime. Checking the types of parameters during runtime. Okay, okay, right. Not only that, all these are applications. What I'm telling you is applications. Okay, like suppose it is also like suppose count function calls. For example, you want to know it. Okay, you want to record how many times this function has been called. Okay, how many times a function has been called, how many times. So count how many times function, how many times how many times function has been called. A function is called. So even I can record that. Not only that, it is also used for uh, adding logging, right? So logging is nothing but, for example, whenever you call the function by sending values, and you want to create one log. Okay, when this function is called, at what time this function is called, what values are sent to this function. Logging is like events, right? So adding logging. So that is add logging to what here logging. So adding logging to what a function. Even this can be done by using decorators. Okay, and not only that, it can also be used like performance checking also, like which you call it as mm, generally you call this as what do you call it as a benchmarking calls. Suppose you want to know how much time this function has been taken to execute or to run. So that is nothing but benchmark how long how long okay a function takes to run. So it is for testing. So even you can use what decorators. Even you can use what decorators. And not only that, you can also use like this decorators even used when you are working with closers also. Sometimes this is nothing but like conducting. Okay, caching mechanism. Now mechanism is nothing but storing. Caching is nothing but storing. Okay, storing arguments, function arguments, and return values. Okay, and return values to reuse if the same arguments are called again and again. Okay, see, storing arguments and return values to reuse to reuse to reuse. Okay, if the same arguments are called again and again. Okay, all this. There are so many things related with this. I'm just writing some of them. I'm just writing some of them, right? Okay. So this is how some of them I've written here. Okay. the testing and all the things you can do it by using what here decorators. Okay, authentication and authorization, checking parameter types, count of function call, adding loggings, checking the performance of the function, conducting the function caching. Like if you are sending the same values again and again, okay. So storing arguments and returning values to reuse the if same arguments are called again, right? All these are different applications of using what decorators. Okay. Then next is how to develop a decorator. Yeah, up to this you understood, all of you. Up, up to this you understood what is the use of decorator is. Online students, you understood what is the use of decorator? Yes, yes or no? Please put in short window. Okay. Yes, yes or no? Understood what is a decorator is? Online students. Okay. So try to respond, sir. Try to respond. Don't sit idle. Try to respond. Okay. Okay. So is a simple thing is like decorator is just like adding some functionality, but you are adding functionality without modifying the existing functionality. You are adding functionality without modifying existing functionality. Okay. So here the next is how decorator works. Okay. How decorator works. Now this is next thing what I'm telling you. How decorator works. So actually decorator itself is a function, right? Okay, decorator itself is a function, and this function is modifying or adding some functionality to existing, right? It is adding functionality to existing. Then how this decorator works? So generally a decorator receives, first point is a decorator a decorator receives receives a function receives a function as an argument. Okay, a decorator receives a function as what? Argument. What decorator will do is it will receive a function as an argument. It will receive a function as an argument. Okay, which function? The function which you want to modify or extend. That function it will receive as an argument. Okay, then the decorator modifies the function's behavior. Okay, it will modify the function behavior. But how it will modify the function behavior is modify it modifies it modifies the function behavior. It modifies the function behavior by defining another function another function. So this another function is called what here? New function. This another function is what? New function. So what this new function will wrap the original function, okay, and added features. So the decorator returns, the decorator returns which function? New function that even wraps the original, that wraps even original what function, that wraps the original function. Okay, right? So the new function here, the new function, the new function adds what it adds, the functionality adds additional functionality, additional functionality, additional behavior or functionality before or after, before or after the original, before or after, before or after the original function is called. Okay, before or after original function is called. See here. So first point is how decorator works. How decorator works. So how decorator works. Okay, how decorator works. So a decorator is a function that receive a function as an argument. The decorator modifies the function's behavior, and how it modifies the function behavior by defining another function, and that is nothing but one new function. And the decorator returns new function that wraps the original function. The new function adds the additional behavior or functionality either before or after the original function is called. Before or after the original function is called. So these are the 4 points. How decorator works. How decorator works, right? Okay. Then what are the basic steps here is for developing decorators. So basic steps. Now next, what I'm telling you is basic steps to work with what here decorators. What are the basic steps to work with the decorators? Okay. First one is developing decorator. First one is developing decorator, and second one is applying decorator. You develop a decorator, and after developing a decorator, you apply the decorator. So here, decorators are reusable. Decorators are reusable. Reusable means so once the decorator is developed, that can be applied, that can be used to decorate either one function or more than one function. So decorators are reusable. Once decorator is once decorator is developed, once the decorator is developed, okay, this can be used with this can be used with one or more than one function, one or more than one function or class, one or more than one function or what is that class. One or more than one function or what class. Okay, can be used with one or more than one function or what is that class. Okay, now this is how it has been done, right? So yeah, decorators are reusable, and once a decorator is developed, this can be used with one or more than one function or what class. Okay, yes. So there are three steps here. One is developing decorator, and one more is what? applying the decorator. Okay. So you are applying the decorator to whom? The decorator is applied. Your decorator is applied to function, or it can be a method. Method means inside a class, or you can apply to what a class. So decorator is applied. Decorator is applied using, so at the rate decorator name what here? Syntax. Decorator is applied by using this particular syntax at the rate decorator name syntax. This is a syntax which is used. This is a syntax which has been used, right? Okay, right? Okay, so let me tell you how to work with the decorators. But actually, decorators, work with the decorators or to develop decorators, you must know how to work with inner functions or nested functions. So, what is a nested function? A function which is written inside what function? So that you call it as what? Nested function or what? Inner function, right? So generally decorators are developed by using which concept? Inner functions are what? Nested functions. Okay, right. Then let us see the examples, right? So first I'm telling you a function decorators means the decorators can be applied to the functions. The decorators which are applied to the function, that you call it as function decorators. Okay. Now let me tell you about this. Okay. For example, there is a function, just very simple. This is very simple and but very much useful. Okay, generally you'll say decorators are two types. Decorators are two types. Two types of decorators. Two types of decorators. Okay, one is called predefined decorators. So there is a predefined decorators, and second one is what here? User defined decorators. You have a predefined decorators and you also have what? User defined decorators. So it means predefined decorators are provided by whom? Python. Or existing decorators are called which one here? Predefined decorators. So the decorators which are provided by Python, the decorators which are provided by Python are called predefined decorators. Okay, like you have at the rate class method, at the rate static method, at the rate property. See, all these are which methods? Predefined. All these are what here? Predefined. Okay, so the decorators, so decorators developed by whom? Programmer are called which decorators? User defined decorators. These are user defined decorators, right? User defined decorators. User defined decorators. So these are, okay, these are application specific. These are application specific decorators. These are application specific decorators, right? So now what we are learning is how to develop your own decorators. We are not using some existing decorators, but once you know how to develop your own decorators, you can able to understand the functionality of what existing decorators, right? So decorators developed by programmer are called user defined decorators, and these decorators are application specific. Okay. Now suppose, now there is one function. I write one function. Okay, this is function based decorators. Means the decorators which can be applied to what functions. The decorators which are applied to the function. So that you can call it as what function based decorators. Okay. So here I write one function called display one. So here display one which display a message. Okay, this is inside display one. I'm taking a simple example. Okay, so there is one more function called display two, and inside this, I'm just writing inside what here display two, and there is one more function is there called display three, and this is one more function where I'm writing inside display three. So I write three functions. One is display fun, display two, and one more function is what here display three. Display one, display two, and one more is a display three. So here I'm calling the function saying display one and display two, and one more is display three. I called all these functions like display one. Okay, right? Online students, are you able to hear my voice, right? You people are very silent, huh? Okay. So display one, display two, display three. Okay. Right. Now what will happen when you run this? What will happen when you run this? So whenever you run this, now you can see inside the display one, inside the display two, and one more is inside what? Display three. But I want this to be decorated. Means I want this message. Okay, I want this message. Okay, so I want this message. Okay, okay, no problem. So I want this message to be decorated. Decorator means I want to display within one box. I want to display within one box. This output I want to display within the box. Okay. Then what I'm doing, I'm developing one decorator. Okay. This is simple example. Huh? Okay. I'm writing a decorator. What is the decorator? Some draw line. Okay. There is one decorator called draw line. So what is a decorator? Decorator is a function. Okay, right? What is a decorator? Decorator is a function only. And this function receive. It is a function and this function receives. Okay. Decorator is a function and this function receive what? Another function. So which function it is decorating? Okay. Which function it is decorating? That function it will take as input. It will receive that function as what here? Input. It is a function that receive a function as an input, that receive a function as what here? Input. That will receive function as what here? Input. Are you getting or not? Okay. So very easy, but you have to understand here, right? Okay, right? So here I'm writing one argument. Argument is now here I write a parameter or argument. So is it predefined or user defined? User defined. This name can be anything, right? Suppose I'll just give the name of this parameter as what function, because it should be a meaningful, right? So I just give an parameter name as what function. Anything you can give, because parameters are local variables, and these variables are identifiers, and identifiers are user defined or predefined, user defined. Okay, so you can give any name, you can give any name. Now this decorator will receive one function. Okay, which function? The function which has to be decorated. Okay, so this function, this decorator will receive one function. Which function it will receive? The function which has to be decorated. But how this decorator, now drawline is the name of the decorator, right? This is receiving a function, and now this function has to be decorated, right? But how it is decorating it? By writing another function. So this function, it is decorating it by writing what here? Another function. What is this another function here? It is a new function, right? I'm just giving a name as what here? New function. This is which function? New function. Okay. So this draw line is a function, it is receiving a function, and this function it is decorating it by writing one new function. Okay, this is a new function. Inside this, now you want to draw some line, right? I just write star. I want this star to be repeated 40 times. And then, see, you are adding some new functionality to which one? This function. Now you are calling this function here. Which function you are calling? The function which you want to decorate. See here. Here I have written this. See here. How decorator works. See here. A decorator receive a function as an argument. Okay. And the decorator modifies the function's behavior. It modifies the function behavior by defining another function. The decorator returns a new function that wraps the original function. The new function adds, see here, the new function adds a additional behavior or functionality before or after the original function is called. Now this is which function is called original function. This is original function, right? So this decorator is receiving original function. This is original function. And to this original function, you are adding one new feature. To this original function, you are adding one new feature. To this original function, you are adding one new feature. And here also you are adding one new feature. So before calling and after calling, I added one new feature. That's it. What is the new feature we added? These are the two new features are added. What is the two new features are added? Drawing the line. So then return. After decorating, it is returning which function? New function, which is nothing but decorated function. So this is nothing but now we develop a decorator. We developed a decorator. Now this is developing. This is nothing but developing what here? Decorator. After developing a decorator, what is the second step? Applying the decorator. What is the second step? Applying the decorator. And always you apply the decorator by using which syntax? At the rate syntax. Now you are applying this decorator. Which decorator? Draw line. To which function? Display one. Now what will happen when I call this? What will happen when I run this? Now you can see. Now this function is decorated with what here? Draw stars. This function is decorated with what? Draw star. Okay. In the same way, I want even this function. Then again I'm writing draw line. Okay, again I'm writing a draw line. Okay, again I'm writing a draw line. Yes. So it means you are decorating it. All these functions are decorated. Means once you develop a decorator, generally you don't modify complete function. Okay, decorators are not for completely modifying the function. It is adding some extra functionality to the function, right? The original function will be there, but you'll be adding some extra functionality. You'll be adding some extra functionality, right? So once you run this, now you can see, yes, this is how it is done. Understood? So one is developing a decorator, and second one is what? Second one is what? Applying the decorator. Developing a decorator, and one more is what? Applying the decorator. So, sir, what is a wrapper? Now, this is a wrapper. This is a wrapper, right? This is a wrapper. Wrapper means, for example, you go to hotel. Suppose you want some parcel, right? You want a parcel, idli parcel. Where he'll put idli? He'll give idli directly to your hand, or will it put in wrapper? He'll put in wrapper, right? What is that wrapper? Huh? Yes, that wrapper is what now? One paper, one cover, huh? One paper or one cover. That you call it as which one? Wrapper. Parida. That is called as a wrapper. Okay. Wrapping. You are wrapping. You are wrapping which function? You are wrapping which function? Display one function into which decorator here? Draw line. Okay. That is a wrapper. Okay. Yes. Now, what will happen? What is the internal? Internally, what will happen? That also we'll discuss. So this example, I'm copying it here. Suppose without decorators, I don't apply the decorator. See here, I'm not applying the decorator here. I have not applied the decorator. No decorator. No decoration. There's no decoration, right? Okay. Now, this is without decoration. Without decoration, right? Okay. It is just like a makeup. Makeover. Makeover, you know it. Makeover. Makeover means same person. Same person will, same person will have different what? Features. Yes or no? That is makeover. Makeover. Same person only. Person is same. Okay. But added some extra functionality. Person is the same, but added some extra functionality. Right? Okay, when you run this, it will run without any decoration. But I want to decorate. Now I want to decorate with what? Lines. Then I added. What is the function I added here? Draw line. So it means display one. This display one function is sent to what? Draw line. Actually, this display one function is, see here. Display one function is sent to what? Draw line. So draw line receive function. Which function it receive? See here. In this case, it receive which function? Display one function. And then it is calling which function? New function. Then it is calling which function? New function. And new function, what it is doing? It is drawing what here? Line. And calling which function? Original function. What is original function? Display one function. And this display one function, what is the message it will display inside display one? Okay. And then print one more line. This is one more line. See here. How exactly it works? Already I've written this. So whenever what is a decorator is a function. Decorator is a function. This is a function. It receives the function. Okay. Now in this case, which function it is receiving? Display one. Which function it is receiving? Display one. Which function it is decorating? Display one. And how it is decorating? I writing another function. And when it say return new function, this will call a new function actually. It will call new function. And what new function is doing? printing stars and calling original function, and then again printing what here? Stars. Again printing what here? Stars. Okay. So again I may apply the decorator at the rate, at the rate. What is the name of this here? Draw line. See that new function name can be anything. Okay. That function name can be anything. Anything. Okay. Once you run this, now all these functions are decorated here. Now let me tell you one more example. Okay. See these notes I'll upload in my Telegram. Okay. This notes I'll upload in my Telegram. Okay. Just download from my Telegram. Okay. Suppose assume that now there is one function. Now just now I said authentication. Okay. Now there is a function called withdraw. Withdraw is a function, right? So those are new. This is my Telegram. So what is my Telegram is, this is my Telegram. This is my Telegram ID. Okay. This is my Telegram. You can join in this. Huh? Right? Yes. This is my Telegram. This is my Telegram. No, not completed. Okay. Now suppose I want. So here I'm writing one function called withdraw. Now here you have a withdraw logic. This is a withdraw logic. There is another function. What is that another function? Deposit. Now this is having which logic? Deposit logic. So there is a withdraw logic and there is what here? Deposit logic. Okay. So any function, I mean any, so I can call this function withdraw or deposit directly. For example, ATM is there. ATM calls withdraw function. From your Google Pay is there. It calls a withdraw function. Phone Pay is there. It calls which function? Deposit function. Okay, but before doing withdraw or deposit, I want some authentication. But here is it asking for any authentication? No. It is not asking for what? Any authentication. Then I want, before calling this withdraw and deposit, I want to ask enter username and password or enter OTP number. Before withdrawing, enter what? OTP number, or before withdrawing, enter PIN number. Getting or not? Okay, suppose assume that there is one dictionary. Now these are some registered users. Okay, assume that these are some registered users. Now this is a username and this is what here? Password. Okay, actually all these things will be there in the database, but I'm not telling database here. Username and password. Again, this is username and this is what here? Password. Okay. So like this, there is a number of users. Okay. Okay, assume that there are some three, four users are there. Okay. Now I'm writing one decorator. What is the decorator is login required. What is the name of my decorator? Login required. Login required is a decorator, and this decorator receive function. Okay, it means before calling withdraw. See here, before calling withdraw, you need to verify. You should ask, okay, enter username and password. Now you are adding some extra functionality to this function. You are adding some extra functionality to this function by writing one new function. But actually I'm giving name as a new function, but you can give any name. Okay. I'm giving a function name as a new function, but you can give any name. Okay. So here you are asking, what you are asking, input what here, username. Here you are asking input username, and here you are asking input what, password. Input username, input what, password, and then you are verifying if a user in a user dictionary, means you are checking is it this user is authenticated user or not. So in this dictionary you are checking is it user is exist, and uh, I'm reading, I'm saying password. Okay, password equal to double equal to user. Okay, users dictionary, you are reading the password of that user. Okay, you are reading the password of that user. If the user is valid and password is also valid, then you allow call which one function. Which function you are allowing to call? Original function. You are allowing to call which function? Original function you are allowed to call. When original function is allowed to call if username and password is valid. Username and password is valid. Original function is allowed to call. Okay. Otherwise, otherwise, what it is doing is, okay, it is not allowed to call it, right? It may raise an error. I'm just returning one message, or I just print one message. Okay, I print one message. Okay, invalid, invalid what? Username or password. Invalid username or password. So return, what it is returning? New function. It is returning new function. See here. Now this is nothing but developing decorator. This is developing, this is developing what, decorator. Once you develop a decorator, you apply this decorator to withdraw. So I'm saying here login required. Now here I call only one function. Okay. So I called which function here? Withdraw. But before calling the withdraw, what it required? Login is required. Before calling the withdraw, what it required? Login is required. Login required. So what will happen when I run this? Now see here, is it called directly now? No. It is asking to enter username. Username NIT123. So users dictionary. What is dictionary name? Users dictionary, right? Okay. So here I suppose if I don't write this, suppose if I don't write this, what will happen? Withdraw is called directly. No authentication. Okay. Withdraw is directly called. But before withdrawing, before calling the withdraw function, what I required? What I required? Login required. I said here login required. And once you run this, okay, now is it withdraw logic is called directly na? No. Withdraw logic is not called directly. Before calling the withdraw logic, it is asking to enter what? Username. It is asking to enter what? Username. It is asking to enter username. Okay. So you need to enter username. You need to input what? Username. Okay. So the username, which is already there in the dictionary, you have to enter. What is the username? Naresh is there. Okay, Naresh and N123. Now you can see withdrawal logic is executed. Withdrawal logic is what? Executed. Now when you run this again, when you run this again, run module. Okay. Now I enter username, but I give some wrong password A123. Now invalid username or password. It means, is it withdraw is done or not done? Is it withdraw function is called or not called? Not called. This function is not called, even though I called it. Here I called withdraw function. But before executing this logic, what it is doing, it is checking for what? Login. Authentication. This is nothing but authentication. In the same way, suppose deposit also there. Now I want this should be secured, right? This should be secured. Means I'm just writing here at the rate. What is required? Login required. Here also said login required. Okay. So here you are searching. You are searching user in operator is used for what? Searching. In operator is used for what? Searching. You are searching user in what? User dictionary. This is nothing but you are searching a key inside what? Dictionary. And you are checking input password equal to the password which is there in the dictionary. Input password is equal to the password is there inside a dictionary. If both are equal, then what you are doing? You are calling the original function. What is the original function in this case? Withdraw. Now, suppose even if I say deposit, deposit is there. Okay, deposit. So both the functions required what? Login. Both the functions required what again? Login, right? So I enter Naresh and N123. Withdraw logic is done. Again, I'm saying Naresh and N123. I can say deposit logic is done. Understood? So these are applications. See, this is what we have. I mean, suppose when you work with Django, when you're working with Django, now use some decorators, right? Okay, when you work with Django, use some decorators like what is that? Login authentication is required. Okay, so you'll try to use so many decorators, but how those decorators works, even you should know that, right? How those decorator works, even you should know that. Correct? Okay, fine. So this is how those decorator works. So now you called a withdraw function, right? Actually, you called which function? Withdraw function. But actually, this withdraw function is sent to which function? Login required function. So login required function is receiving what function? What is the function it is receiving? Withdraw. And then calling which function? New function it is calling. And new function is asking to enter username. And new function is asking to enter what? Password. And then you are checking whether this username password is valid or not. If it is valid, then it will call the original function. Otherwise, it will display a message invalid username or password. Right? Now you can write a decorator. Okay, now you can write a decorator. So you can write a decorator. Now this is one example. Okay, now suppose for example assume that yes, I want to write some more examples, sir. Okay. So just try to understand. You are not changing the function. See, decorators are not for changing the function. You are not changing the complete function. You are adding some extra functionality. Okay, na? Okay. The original function logic will be as it is, but you are adding some functionality. Okay, right? Okay, right. Now, next is, for example, okay, fine. So, even I want to tell you some more decorators like, now all these are examples, right? All these are applications of decorators. Okay, right? That is, I said, now suppose, now we develop this one, authentication we develop, right? Now I want to develop a decorator which will check for what parameter types. I want to write a function that should allow only which type integer types. I want the function should allow only which type list type. Okay, suppose when you work with conversions, okay, when you work with conversion functions, will you get errors or not? Okay, suppose integer function is there. Suppose I said s1 equal to 1.5. Can I write a equal to integer of, can I write a equal to integer of s1? No. This gives what here? Error. Because you cannot convert this string to what? Integer. Because whenever you convert string to integer, the string should contain which value? Integer value. Yes or no? The string must contain integer value. It means this integer is having one decorator. What it is doing, it is checking is a string contain integer value or not. Even I want to develop such kind of decorators. So can you develop those decorators? Yes or no? Yes, you can develop those decorators. You can develop those decorators. So we'll develop. Okay, we'll also write decorators with arguments. Now in this case, we write a decorators without arguments. Okay, here we write a decorator without arguments, but even you can write a decorator with arguments. You can also send values. You can also send values to what decorators. Okay, that we'll discuss, but not today. Okay, now tomorrow we'll discuss with like decorators with arguments and developing a class-based decorators, and we'll try to see some more applications like real-time examples related with what decorators. Okay, but not today, but we'll see tomorrow. And now this notes I'll be uploading in my Telegram. Okay, so this is my Telegram ID, right? So please join this Telegram. Okay, right?